Welcome to CW 3.2. Today we'll be talking about probability. So there's not much to write down here. The main thing for probability would be this. It's a fraction. You have what you want on the numerator, and then your denominator is all possible outcomes. And that's really all you need to do these problems. So for our first example, it says 2 ordinary 6-sided dice are rolled. What is the probability of getting a sum of 8? So to do this one, we're going to do what's called making a chart. You might have done this before in a previous class. This does make it easier for us to organize information. So 1, 2, 3, 4, 5, 6, that represents all the possibilities of one die. And the other die will be right here. Now we're doing this because it says, what's the chance of getting a sum of 8? So we're going to have to figure out a way to organize information because there's no easy way to calculate this answer. Now I'm going to add up all the numbers here. So this would be 2, 3, 4, 5, 6, 7. And let's just fill it in. We're just adding all the numbers here. You notice it makes a very nice pattern. Okay, so this is going to represent everything that could possibly happen. We're looking for an 8, so let's just highlight those. So the answer is 5 out of 36, because there are 5 things we want, and there are 36 things that could happen. And we're done. Next question. You're dealt 1 card from a standard 52 card deck. Find the chance of getting dealt a heart. So there's 2 ways to do this. One way is going to be making a slot or slots. And this way is not that hard. You just got to think about it. There are 13 hearts in the deck, and there are 52 total cards. So that would be 1/4. Now, in case you don't know how I did that, for this unit, you should probably play a game of cards so you get more comfortable with how cards work. Just so you know, there are 52 cards total. There are 4 what we call suits. That would be hearts, clubs, spades, diamonds. And each suit, within each suit, there are 13 like values. Then that would be like ace, 1, 2, 3, all the way to king. So make sure you study this information or just play a game of cards and it'll come naturally once you play a couple games. Now the other way to do this is actually combination. What you can do is say, well, the top would be 13C1. This 13 represents the 13 possible hearts, and we're picking one of them. And we're dividing it by 52C1. And notice how you get the same answer, 13 over 52, which is 1/4. Do a couple more. If 1 card is randomly selected from a deck, what is the chance of getting a king or a queen? So again, I recommend just drawing a slot and just thinking about it. There are 4 kings and 4 queens. So that's going to be 8 out of 52, which is going to be 2 out of 13 once you reduce that. And you could also do combination too. You could do the same thing. 8 choose 1 over 52 choose 1. Let's try another one. If you draw 1 card, what is the probability of not drawing a king or queen? So what we're going to do is actually use our previous answer, because this is the chance of getting a king or queen. We want not drawing a king or queen. So what we're going to do is a concept called the complement. So the concept of the complement is this, that if you have some probability of an event A occurring, the probability of not A, so that's what this symbol means right here. That would mean not A. If you add those two things together, you get 1. So that's going to be a helpful concept to note. So to solve this, all we're going to do is simply do 1 minus our previous answer, which would be 11 over 13. Okay, let's try our next one. What is the chance of drawing a king or an ace? So this is basically the exact same thing we did here. That's going to be 2 out of 13. That's pretty easy. Now this one, what's the chance of drawing a king or a club? Now this one's a little more complicated, because if you've played cards before, you might realize there's overlap here. If you simply do this, there are 13 clubs, and you add to 4 kings, and you divide it by 52, this is incomplete, because this is counting the king of clubs twice, right? Because you have the king here and the king here. So to fix that, what you can do is subtract the overlap. This is our overlap, which would be 1, the king of clubs. So by doing that, you fix the problem, and then we're going to get 16 over 52, which would be 4 over 13. Now the other way you could do or is simply just think about it. 13 clubs and then 3 kings left, because you already counted the king of clubs right here. And that's over 52, which is the same thing. Let's do a couple more. What is the chance of drawing 2 face cards in a row? So again, we can use the slot method here. So this would be like your first draw. This is your second draw. We want 2 face cards in a row. So face cards, that's going to be ace, king, queen. So face cards are going to be defined as having a face. So that's going to be king, queen, jack. Which means total, there are 12 face cards. Because that would be this times 4. That's how you get 12. So for the first draw, the chance of getting a face card would be 12 out of 52. For the next one, it would be 11 out of 51. Notice how it drops 1, because if you get a face card here, that means there are 11 left and only 51 cards left. Now I'll plug that in our calculator. Okay, and notice how I use a fraction button here, right here. 11 over 221. That's our answer. Now you could use combination here, and to use combination, you do something very similar. You say there are 12 face cards, we're choosing 2 of them, and this should be divided by 52, choose 2. So that's all the ways you can grab 2 face cards, divided by all the ways you can pick 2 cards of the 52. So let's go back to our calculator, and we're going to see it's the same answer. Okay, so there's our answer, and yep, we can see that is in fact the same thing. That's 11 over 221. Now here's the last one. What is the chance of drawing 2 face cards in a row if the card you drew is put back in the deck and reshuffled? So this is super important. If the cards are reshuffled, that actually changes everything. At this point, you actually can't use combination. Unless you do like some pretty crazy things, like some fancy techniques. Once you put the card back, everything changes. Like all the probabilities reset, which means you keep it simple and just use slots. the first chance would be 12 out of 52, but if the cards reset, that number goes back again, 12 out of 52. So put it back in your calculator. And there it is, 9/169. And there's your answer.